Hello, I'm Sophia.
I'm Sophie.
I'm Mariana.
And I'm Riya, and today we're going to be talking about extremophiles in the industry. First off, extremophiles are organisms that thrive in extreme environments with the help of their enzymes, extremozymes. Because of this, they're incorporated into various parts of society. Today, we're going to be focusing on thermophiles, radiophiles, and halophiles.
So, our overall goal is to use extremophilic technologies from existing industries on Earth to develop uses in space and on Mars.
In order to accomplish our goal, we first had to decide on which extremophiles to research and technologies on Earth that utilize those extremophiles. Then, we have to research characteristics of the extremophile we choose. Next, we have to derive ideas for how these traits can be used in technologies in space and on Mars.
First, we research current and potential uses of extremophiles on Earth as well as their impacts. Though not yet prevalent, the use of halophiles to make bioplastics has huge potential because of its positive environmental impacts as well as its lower energy usage.
Thermophiles are widely used as an excellent choice for producing yogurt. Lactobacillus bulgaricus is a probiotic that has the potential to treat and cure a variety of disorders.
D. radiodurans, a specific type of radiophile, is able to clean up radioactive waste and spills by consuming the pollutants of a spill.
Here are some possible applications of extremophiles in space that we brainstormed. The halophile Halobacterium salinarum is used in the production of Bacteria rhodopsin, a protein that serves as a light-driven proton pump. Although not yet used commercially, a potential application for this protein is the conversion of sunlight into electricity. Although there are already existing systems in place on spacecrafts to convert sunlight into electricity, perhaps an alternative solution, such as the use of halophiles, can find some use in other areas, such as to potentially power other smaller devices.
Thermophile Trichoderma spp has been known to suppress the growth of plant pathogenic microorganisms, prevent root rot disease, tolerate unfavorable environments, which in turn aids in regulating the rate of plant growth. If astronauts will be growing some of their own food and growing their plants, they cannot risk any dangers since they will be so far away. Using Trichoderma spp could help reduce the number of issues that could present themselves on the way to Mars.
Gold is a material that is utilized in spacesuits because it can reflect infrared light and protect an astronaut's vision from the sun's rays. Although gold is scarce, D. radiodurans has been able to synthesize gold nanoparticles in an environmental friendly way. Furthermore, studies have shown that D. radiodurans has successfully demonstrated the formation process for gold nanoparticles through the interactions of various gold ions.
Here are some possible applications of extremophiles on Mars that we brainstormed. On Earth, many industrial processes result in highly saline water. Several processes involving halophilic microorganisms have been proposed for the treatment of such waters for recycling. The existence of extremely briny water on Mars is supported by evidence such as imaging data and meteorites. Research shows that certain halophilic microbes, such as the bacterium halonairobium, may be able to survive in a Martian brine. This could mean that potentially the use of halophilic microorganisms for water treatment could also extend to Mars or other planets with briny water.
Biomining is used with microbes to extract valuable elements from rocks and soil, such as copper. ESA scientists announced that they have successfully extracted rare earth minerals from vessels inside a small bioreactor on board the ISS using bacteria. The BioRock experiment was designed to simulate the microbial harvesting of elements from rocks similar to those found on Mars. The BioRock experiment demonstrated that biomining is one method with future potential for extracting useful elements from rocks to support a long-term human presence beyond Earth. The use of thermophiles in this scenario could be advantageous because the higher operating temperature will increase the rate of the process while also eliminating the energy input for cooling the system.
Radiophiles have the ability to withstand extreme radiation. Prolonged exposure to UV rays can lead to potential skin cancer due to DNA damage. However, the metabolic products generated from radiophiles allows it to protect an organism's DNA by repairing it. Thus, by incorporating it into the cosmetic industry through the form of sunscreen or other facial products, D. radiodurans will be able to hopefully prevent these cancers from occurring when on Mars.
Overall, extremophiles prove a more effective, eco-friendly, and unique way of developing technologies and establishing industries on Earth, in space, and on Mars.
One of the highlights of this program was learning about extremophile and their uses. One of our challenges is that since we're hypothesizing and modeling possible future applications, it will be difficult to find data and information that prove our solutions to be available.
Overall, we are forever grateful for this opportunity and the skills that all of us have learned and developed.
Thank you everyone for your time.